Hello everyone, welcome to the class ECE317 Digital Signal Processing. Today the ECE317. Today is the class for the 12th week, Friday's class. Alright. Okay, today we will consider something related with phase spectrum. Phase spectrum, the angle of edge of e to the j omega. We study something related with this. We have studied something like we have the all-pass filter, right? In all-pass filter, the magnitude of the frequency response is always keep to 1. Now we consider phase. Actually, later we will consider case if this one equal to some like not constant, it's gives related with some constant. What will happen? Now, first of all, we do some example to see what is this one, and we check some examples. Let's consider FIR filter firstly. Edge of e to the j omega. It is a FIR. I use 2 plus 3 e to the negative j omega plus 2 e to the negative 2 j omega. Okay, consider this one. Then you can see, what is the impulse response. This should be 2, 3, 2, right? 2, 3, 2, 2, 3, 2, the constant coefficients, right? This is n equal to 0. We know this is this is a FIR. This is a causal. This is stable, right? We can have this kind of things. Then what is the phase angle? To write it in a phase angle, you should know h e to the j omega equal to the magnitude times e to the j, then angle of the e to the j omega. So you want to know this part? One of the way is you rewrite this frequency response in terms of these. This part, you know what? This is a real function, right? Real and positive. Real and positive. And then here's a e to the j something. So you need to write it in this way. Okay, let's look at this example. The edge of e to the j omega equal to, can we remove some common e to the j something term outside? Okay, so this one we have 1. This one we have a different one. And this one we have 0. But this is in this example, this is 2, this is also 2, right? The coefficient. So we can try to merge them together. Yeah, as I said, this is 1, and 1 plus 2 times 1 plus 1 to the 2j omega, and plus 3 e to negative j omega. Then I remove these, so I move this outside, e to the negative j omega. And here's a 3. Here's a 2 of the 1. I remove this, come out, so I have this one left, right? And this is a 2 of j omega. The 2 of negative j omega. I remove 1 outside, so I have another 1. Okay, right this way. Then this is what? This is cosine omega plus j omega, j sine omega, and plus cosine omega minus j sine omega. When you do summation, these two cancel. These two cancel each other. So it is a 2 of cosine omega. So finally I have 4 cosine omega plus 3 and e to the negative j omega. Alright, almost done. You can see here, this one is this part, right? This one related with this, it is real, but we want it positive, right? So we need to do more work. We want it positive. Whether this is a positive, we can have a look. 4 cosine omega plus 3. You can have a graph. So cosine will be a value between negative positive 1. So this is between negative 4 to 4, right? The value is between negative 4 and 4, and plus 3. So this is a value from negative 1 to plus 3, right? To 7. Negative 1, and the center will be center 0 plus 3. So this is 3. This 3 line, and the cosine. So this curves look like this. This is omega, right? Yeah, cosine. This is 4 cosine omega plus 3. And we have this part is negative, and this kind of part is positive, right? Is a positive. So when omega is positive, it is good. This is positive, right? When it is negative, you need to change it to be positive. Positive. So we will write this one. Okay, copy this. Equal to, I say, absolute value of 4 cosine omega plus 3. This is the magnitude part. And here we have two cases. I say this is a beta, and I get beta. It's a gamma of t, a gamma of omega. Gamma of omega were equal to two cases. One case is just this one, so e to the negative j omega. And in this case, when omega is located in this case, in this kind of interval, here will be negative e to the negative j omega. I write in two parts. And this one, actually, this is e to the negative j omega plus pi. It's this one. It is this one. Alright. And in which case this? Okay, you need this number. This number, this one, according to 4 cosine omega plus 3 equal to 0. Then cosine omega is negative 3 over 4. It will be some value, right? It is a arc cosine of negative 3 over 4. Okay, this is omega. I say this is omega 1. Omega 1. Then from 0 to omega 1, we have this. And from omega 1 to, actually, we only consider 0 to pi. Okay, 0 to pi. All the rest will be periodically, will be a repeat of this part. So here is omega is larger than omega 1, smaller than pi. We use this one. We use this one. And here we suppose omega is between 0 to pi. We only consider this part. Alright. Then we get our result. This is just this one. This one I can write this is e to the negative j omega, or e to the negative j omega plus pi, right? So here I just copy it. This is omega 1. Then what is the phase? What is the phase? Phase of H will be this part. So it is with negative. It is negative omega if 0 smaller than omega, smaller than omega 1. If it is negative omega plus pi, if omega is between omega 1 to pi, where omega 1 is that number, cosine, negative 3 over 4, and here the omega, the overall omega is between 0 to pi, and we know the angle, the periodic with period with period 2 pi, and it is odd in negative pi to pi. It's odd function. Alright, so now we know what is this function. It is odd in negative pi to pi, and from 0 to pi with this function we can describe in this way, and it's periodic with 2 pi, so every 2 pi it will repeat. And if we give the graph, it will look like from 0 to omega 1, then omega 1 to pi, and symmetrically here's a negative omega 1, negative pi, and okay, so this part from omega 1, 0 to omega 1 is a straight line like this. Slope is 1, right? It is just negative omega, and it is odd function, so this side will also look like this. And from omega 1 to pi, it is negative omega plus pi. Actually here I write this way is minus pi. I use is negative omega plus pi. I remove this. It should be same thing, right? Same thing. Here I put in minus. The minus pi or plus pi, you get same angle, right? Minus pi plus pi, you get same angle. 2 pi is 0. 2 pi as angle, it is just 0. So I write this way. I can put the functions here. Plus pi, so omega is or be things like this. Let me see. Omega 0, then pi is somewhere here. Pi is somewhere here. Then start from pi and we slope negative 1, so it's a curve like this. So it is straight line like this, and symmetrically as a odd function. So this side will be something similar. So this point will go to here, and this point will go to here. So something like this. Okay, so we have three segments from negative pi to pi, and then you repeat this one where we have the same piece, then a long one, and the small piece. Okay, this is a 3 pi omega. This is omega. So you repeat this piece by piece, then you have the angle. They have the face angle. So we have graph looks like this, and function like this. Right. And actually at the same time we also have the magnitude, right? Magnitude, it is absolute value of 4 cosine omega plus 3. Yeah, this absolute value, you need absolute value. Magnitude is always positive, and this one, it will be a kind of, this is a negative 1, then 3, then 7, right? So it will be a cosine wave like this, but we only need a positive with absolute value, so it will look like this. Yeah, something look like this. And this time it is a even function. This time is an even function. This is an even. This is odd. Even function. Right? So you can also have both. You have both. We can have a look in my lab. I use I'm writing a function. Okay. Not 341. It's 17. Okay, and it lecture for the 12th week. 12th week, Friday. Okay. That's all right. what is our function? It's a 2 is here. H is here, right? H is here. H is here. So we can just use, let's say, HW, alright. H in the frequency domain. It is 2 plus I need W first. W equal to whatever, like negative 10 to positive 10 with step these to 10. Okay, this is W. Then H, okay, as a capital H. Capital H in frequency domain, it is 2 plus 3 times exponential power of negative j times omega plus 2 times exponential power of negative 2 times j times omega. Alright, so this is the H omega. Actually, use MATLAB, you can just plot it, you can see it. Plot. I have omega, I have the angle of H omega. I can plot both. How to say? Subplot, right? Subplot 2, 1, 1. I plot these. And 2, 2, 1, 2, 1, 2 or 2 to 1. I forgot. Sorry. Let's see here. Subplot. Oh. Subplot 2, 1, 2 and plot. 2, 1, 2, 2, 1, 2 and 2, 1, 2, 2, 1, 1. 2, 1, 2 and 2, 1, 1. Two, 1, 2. 2, 1, 1, 2, 1, 2. Oh, so first 2 and 1, that means the, anyway, I just, okay, the first one I give the absolute value. The absolute value, that's a magnitude, and angle is a phase. Angle is the angle, right? The phase. Okay. Run it. I didn't say. Save it. Alright, this is the graph. Oh, okay, the middle part, they connected together. Okay, this is good. My graph, when I draw it, it is not good. Here, look at my graph. Oh, it's good. It's not good. These two, actually, these two, these points should be merged together. So these two lines should be one line. They're connected. And this one should be go to here. They connected to next part. This one should start here. Okay, now this. See here. All right. So, so these two, when you have two pieces, these two, they merge together, they connected together. So the graph should look like this. This part, yeah, from 0 to pi, right, this is one cycle. And from pi to 3 pi, this is another cycle. And to 3 pi is here, then another cycle. And here's this is that 4 cosine plus 3, and here's a negative of 4 cosine plus 3. When it is a negative value, and you take absolute value, you make it positive. So this is a magnitude, this is a phase, this is a phase. Alright, okay, this is one. And we can see another example. You can see another example. Example 2. I use h of z. Now I use IR field 1 over 1 minus 1/2 z to negative 1. Okay. The RC is z larger than 1/2. Okay, so we use this h of z. Then we know this is IR field, and the z is in larger side, right? Larger than larger than 1/2 is this is a causal, right? Causal, and 1/2 larger than. Then the unit circle is a part of RC, so it is stable. It is stable. Okay. And you can also think the pole is pole absolute value smaller than 1, because this is 1/2, right? Smaller than 1. You can also think like that. It is causal, and the pole is smaller than 1. Then this is stable. Okay. All right. Then what is the phase angle? Phase angle. We can use the graph to see. That will be easy. We start from here firstly. This is 1. Okay, I change this. I change h omega now is 1 over. Is 1 minus 1/2. 1/2 is 0.5. Then times. Okay, this one. Alright, this is a h omega. Then we can just run it. What is it? Okay, we got this one. What is this? Anyway, I gave the graph firstly. So we have two graphs. It should be this is a magnitude. Not the magnitude of let me copy this to my notes. Sorry. Okay, this one, it is from 0.5, more than 0.5, maybe, but 0.5 is some point here. Then the maximum value is 2, so it looks like this. And 0 is here. Omega equal to 0 is here. Okay. Things look like this. And here's omega is 6 dot something, is 2 pi, right? 2 pi. Then the middle should be pi, right? This is pi, this is negative pi. And this one, if I just give one cycle, it will be from negative pi. If something looks like this, right? Negative pi to pi, like this, and then negative cycle. Here's another cycle, like repeated. It's not so symmetric. This slope is sharp, and this is not so sharp, right? Yeah. Okay. So the things look like this. Things look like this. This is the angle of H. The phase spectrum. Phase spectrum. Of course, this is just a graph. If you want to know the function, you prefer give a function, right? So what is the function? You need to work like this. H of z, the magnitude, there will be 1 over magnitude 1 over the magnitude of this term, not e to the j omega, e to the negative j omega, and we have this magnitude. So this is 1 over 1 minus 1/2 cosine omega minus j sine omega magnitude. Then the magnitude will be real part square plus imaginary part, it is a negative positive, so 1/2 sine of omega square and square root. So it is this one. This is a function. If you want to do some simplify, I think we can, right? This is 1 minus 2 of these, which is just 1, and the cosine omega, and plus 1/4 cosine omega square, and this is another 1/4 with sine omega square. Okay, so this is just 1, right? This is 1. So I have 1 plus 1/4, 1.25 minus cosine omega square root 1 over 8. So we have it just like this, right? The magnitude is just like this. If you want to calculate more, no more, just like this, right? Can make it to more simplified. That's it. Then the angle. What is the angle? This time it is hard to write it in this form. If you want to write this directly in this form, it's not so easy. So this time we need to consider like this. It is the angle, right? You look at the graph. A complex number, a plus bj. This will be the angle. This will be angle. The angle will be, if I take cosine of this angle, will be the square root of a squared plus b squared, the magnitude in the denominator, and the numerator will be this length, right? That is a. So cosine theta is this one. So this is arc cosine of the a over this one. A is the real part. Okay, now is 1 over it. 1 over it, we will think is okay. This is 1 over it, right? So this is a negative angle of 1 minus 1/2 e to the negative j omega. You see like this. It's negative. This h is 1 over this, so the angle will be negative of the denominator. Angle is negative of it, and the negative of this. This is what this angle will be arc cosine of a, the real part. The real part we know it is 1 minus, right? It is just this one, right? This one, it is this one. This one, the real part is 1 minus 1/2 cosine omega. Then divided by the magnitude. This is the magnitude. Magnitude is just this one. So it is 1.25 minus cosine omega. So like this. So this is as a formula, it's a very complex one, but we can have it. All right, we can have it. And in some special case, if the transfer function, if the system function is good enough, this one you can do some simplify. But usually, for the phase angle, the function looks like this. It is some arc cosine, and the inside part is some fraction, because it's a over a squared plus b squared. So look like this. All right. Okay, here now we know how to find the angle of this kind of thing. And the third one, I have third case. H of z equal to, now I have 2. I have 1 minus, like 1/2 z to negative 1. Here's 1 minus 1/3 z to negative 1. Maybe I have more. Okay, just use 1 0 and 1 pole. Okay, so for this one, for this one, now the angle will be more complex. So now the angle of h of e to the j omega will be the angle of 1 minus 1/2 e to the negative j omega minus 1 minus 3 e to negative j omega. So we can calculate by this way, right? This one minus this one as an angle is minus. Then so this one is same arc cosine of the real part of these. There will be 1 minus 1/2 cosine omega, and then the magnitude of these will be 1 plus 1/2 square and minus 2 times this 1/2 e to the negative not e to the negative, is a cosine omega. Let me see, I have the real part is 1, 2 times 1, this is cosine omega, then square root. So it is square of these plus square of half sine. So the sine square, cosine square merged in this term, and I have this, and that one is minus arc cosine. Numerator is now 1 minus 1/3 cosine omega, and here square root of 1 plus 1/3 square, and minus 2 times 1/3 cosine omega. It's like this one. Like this one. The formula will be look like this. This is a case we only have 2 poles, 1 0 1 poles. In general, for case h of z, you have 1 minus 0 0 1 times z to negative 1. Here z1 means zeros. I use okay, zeros. 01, 1 minus 02. Look 0. Sorry, I change the notation. I use 1 minus zeros. I use r for zeros. Okay, r1 z to negative 1. 1 minus r2 z to negative 2 until 1 minus rn z to negative n, and here's 1 minus pole 1 z to negative 1, 1 minus pole 2 z to negative 2, 1 minus pole m z to negative m, and before it you have a constant k. Then the angle of h e to the j omega will equal to the angle of k plus summation of the angle of 1 minus r I z to negative 1. I run from 1 to n, and minus the summation of angle of 1 minus poles, i's pole z to negative z to negative 1. Here the I will run from 1 to m. So the angles look like this, and each this term, angle of 1 plus minus angle of 1 minus, I say any constant a. Alright, this one will be arc cosine. It's a fraction. 1 minus a e to the now it's not z. Z is e to the negative j omega. Z is e to the j omega. This z. Alright, this is z. So here's e to the j omega, negative j omega. Now it's cosine. Okay. Angle of 1 minus a e to the negative j omega will equal to arc cosine. This is a fraction. Numerator is 1 minus a cosine omega. Denominator is 1 plus, let me see, there will be a squared and minus 2a cosine omega and square root. Okay, so like this, the angle will be a formula like this. It's very long. So these kind of things prefer you can work use computer. You can prefer run use computer. If omega is given, you want to know the angle, you just plug in. Then plug in here, you use the formula. You let the computer to work on it. All right. So this is the first case. This is the most general case. All right. Next, let's see what happened when we give an input. We give an input to a system. X of n, we give an input. Right, we have this one. Then in the phase angle, so what will happen? What kind of change is caused by the phase angle? So we consider the case x of n like just the cosine of some omega 0 n. Then what will be y of n? Y of n will be magnitude of h e to the j omega 0 times cosine of omega 0 n plus the angle of h of e to the j omega 0. Right, we have these, and similar for x of n equal to e to the j omega 0 n, or x of n equal to sine of omega 0 n. Right, similar. You change the magnitude by times this as a magnitude, as an amplitude, and you add a phase angle inside the cosine or sine or the exponential power. Right, the omega 0 is replaced by omega 0 n is replaced by this one. Right, similar. Okay, then we can have a look if how it looks like. We know this is change on phase, right? Change on phase. Oh, let me write one more step. I will explain it later. Magnitude and the cosine of omega 0 is n minus negative angle over omega 0. Yeah, we write it this way. Okay, writing this way. Actually, this is a kind of delay. We still use the previous examples. H of z is 2 plus 3 z to negative 1 plus as a 2 3 2 3 2, right? Yeah, 2 3 2 here. 2 3 2 2 3 2 z to negative 2. Okay, I use this one. Then what happened? The output. And x of n, I suppose this is a cosine of omega 0. I just use 1, alright. That means omega 0 is 1. Omega 0 is 1. Then y of n will be what? Is a magnitude of h e to the j omega 0. Omega 0 is 1. And the cosine of n plus the phase angle. Right, it's this one. So it is magnitude of 2 plus 3 e to the negative j plus 2 e to negative 2j. Well, I just leave it. Yeah, this one, if you calculate it by hand, there will be a lot of calculation, but we can use computer to see what it is. All right. Let me go back. this H omega, right? I have this H omega. I have this H omega. Now omega is not a vector, or not here omega is run from negative to positive 10 order omega, right? Now I just want omega equal to 1. Then I have H omega. I can see what is H omega, and absolute value of H omega, and the angle of H omega, and you can see. Alright, the answer is here. I have the magnitude is this one, 5.16 something. So omega 0 is 1. So this is a 5.1612. And the angle of this H omega is 1 is negative 1. So we have this, and then we can see the output will be 5.1612 times cosine of n plus 1. So this will be the output. And we can see what will happen here. I gave two functions. Let me see. One is I need to run this. If I give this one, I can use the H for the system, which is a field defined by a fraction. The numerator will be a 2, 3, 2, and no denominator. Denominator is just 1. It is not really a fraction. And then I have the input. I use n equal to from 0 to like 20. 20 is my 20. Then I have xn. The input is a cosine of n. Cosine of n. This is xn. Then I run yn will be with it's a sim. It's a linear simulation. Like I have system is h, and input is xn with times n. Oh, am I good? Yeah, let's just run it. What happened? Nothing happened. That means it works well. I want to see. Okay, let me plot n and yn. Oh, now it's a different graph. I need it. That is figure 1. Figure 2. Okay, this is the output. Looks not so good. Okay, we can work like this. I give a t. T is also run from 0 to, let me see, n to 20. So this is also from 0 to 20. But I need a step. It's a continuous case. I give a 0.01 as a step, and I gave a yt, okay, yt, yt is just the output. We know the output, right? What is the output? This one, 5 dot, okay, times 5.1612 times cosine of, now it's t plus 1. So this is a continuous one, and then I plot t and yt as well as n and yn, but n and yn I gave a circle to for the point. Okay, so this what times works. Something wrong. Yt is a cosine, or still n, I should still s. Sorry. Right. Yep. Okay, let me see. That is a t plus 1. It should be the same feature. I think I didn't make it good. The angle, what is the angle? Oh, angle is -1, sorry. Okay, that is -1. Here's a -1. Okay, then here it should be -1. Ah, yeah, I put angle is -1 here. But then here I put the +1, should be -1. Alright. Yeah, I need to correct it. Okay. Now it's a -1. Alright, you can see like this. So the output are those discrete time signals. So according to those circles, you can see after behind that circle is a cosine wave. This cosine wave is a shifted cosine. It's shifted cosine, right? We know it is shifted by 1. Yeah, shifted by 1. So it looks like this. It's shifted one. You can also put the one didn't shift it here. I put the xt, which is a cosine of t minus 1. Just t. This is original x, right? Original x. If you want, you can also put xn. Oh, I already have x. This is xt. So if you want, I can put also t and xt, then t and yt, the n and xn. I use a diamond for x. Okay. Alright, like this. The original signal is this diamond. It's diamond guy, and the background curve you can think it's that blue curve, right? That blue curve. And after you go out from the system, then you have those circles. Those circles actually they are pointed from that green way, right? Green way. Here in the beginning, we have several points. They are not on the curve. That is because when we run it in MATLAB, it will start running from time equal to 0. And when we do the filter in the theoretically, mathematically, we consider the signal is start from negative infinity to positive infinity. But in MATLAB, we can only start from time equal to 0. Actually, it will end at here. I choose time 20. It will end it at 20. So the system just run from 0 to 20. Then in the beginning, we have something wrong, something not. We have some errors, and after a while, actually all the points they will have some error, but the error is smaller and smaller, so you can't see it. But the first, I have 1, 2. I have 2 points. They are not exactly as same as the sine waves. All right. Yeah. Okay. Almost the time. Actually, if you are interested, you can also try another function. Right? We have different function. Today different system. We have two systems. One system is this system, it's a FIR system, and another system we also try the that is 1 over 1 minus half z to negative 1, right? We have that one. If you're interested, you can try this. You just change a little bit in this program, you can see what happened in that system. All right, yeah, okay. And I will post this program in the Blackboard. So if you're interested, you can download and make some change, and then you can run for different system. Okay. All right, that's all for today. See you next time. Bye bye.